Finally, released, the image from the James Webb Telescope that we've all been waiting for. The James Webb Space Telescope has made headlines once again with its latest discovery. This new release focuses on the telescope's observations of some of the universe's most distant and enigmatic phenomena. The latest data from JWST provides an unprecedented view into the early universe, revealing details about black hole mergers and their role in cosmic evolution. This discovery is set to reshape our understanding of the universe's infancy and the formation of the earliest black holes. One of the most significant findings from JWST is the detection of the earliest known black hole merger. This event occurred just 740 million years after the Big Bang, a period when the universe was still in its infancy. The merger involves two black holes that coalesced into a larger one, marking a crucial milestone in the study of cosmic evolution. The system, known as ZS7, was observed in a region of space that corresponds to a time when the universe was still forming its first galaxies and cosmic structures. This observation provides invaluable insights into the early growth of black holes and their role in shaping the universe. The black hole merger detected by JWST offers crucial information about the early universe's conditions. The fact that such a merger occurred so early in cosmic history suggests that black holes began forming and merging much sooner than previously thought. This early merger implies that the seeds of these primordial black holes were likely present shortly after the universe's initial phases. The data from this discovery helps astronomers understand the processes that led to the formation of these early black holes and their subsequent growth, such as the role of initial mass distribution and accretion rates. By studying the properties of these early black holes, including their masses and spin rates, researchers can gain insights into the conditions that prevailed in the early universe. This includes understanding how the rapid growth of black holes influenced the formation of the first galaxies, and how these massive objects interacted with their surrounding environment. Such findings are instrumental in refining models of cosmic structure formation and black hole evolution. The detection of this early black hole merger has significant implications for our understanding of black hole formation and growth. It challenges existing models that suggest black holes grew primarily through the gradual accumulation of surrounding matter, such as gas and dust. Instead, the early formation and merger of black holes indicate that they might have also formed through alternative mechanisms, such as the direct collapse of massive primordial gas clouds or the merging of smaller black holes from earlier cosmic epochs. This finding suggests that black holes could have achieved significant masses much earlier than previously believed. The presence of these early black holes prompts a re-evaluation of theoretical models related to their formation and growth in the early universe. It also highlights the need for further observations and simulations to better understand the conditions and processes driving these early black hole mergers. Such research will be crucial for refining our models of cosmic structure formation and the evolution of the earliest black holes. The success of this discovery underscores the advanced capabilities of the JWST's instruments. The telescope's ability to observe in the infrared spectrum allows it to detect light from distant and faint objects, such as early black holes, that are not visible in other wavelengths. The near-infrared camera and the mid-infrared instrument played crucial roles in capturing the detailed images and spectra necessary for this discovery. These instruments are designed to penetrate the dense cosmic dust and reveal objects from the early universe, providing a clearer picture of cosmic events that occurred shortly after the Big Bang. JWST's observations of early black hole mergers contribute significantly to our understanding of cosmic evolution. By examining the early universe's structures and phenomena, the telescope provides critical data on how the universe's initial conditions influenced its subsequent development. The detailed imaging and spectroscopy offered by JWST allow scientists to trace the formation and growth of galaxies and black holes from their earliest stages. This research helps piece together the timeline of cosmic events, revealing how the universe transitioned from a hot, dense state shortly after the Big Bang to the complex structure we observe today. The insights gained from JWST's observations are crucial for constructing accurate models of cosmic evolution, including the role of black holes in shaping galaxy formation and large-scale cosmic structures. Additionally, these findings refine our understanding of the mechanisms driving the growth of early black holes, providing a more complete picture of how these massive objects influence the evolution of the universe. The discovery of the earliest known black hole merger opens new avenues for research in astrophysics and cosmology. Future studies will focus on analyzing additional black hole mergers and other early cosmic phenomena to build a more comprehensive picture of the universe's early history. Researchers will also investigate how these early black holes influenced the formation of the first galaxies and the growth of large-scale cosmic structures. The continued observations by JWST and other next-generation telescopes will be essential for addressing these questions and refining our understanding of the early universe. The latest discoveries from the James Webb Space Telescope represent a major advancement in our understanding of the universe. The detection of the earliest known black hole merger provides crucial insights into the early formation and growth of black holes, challenging existing models and opening new research directions. The advanced capabilities of JWST's instruments have enabled these groundbreaking observations, highlighting the telescope's role in uncovering the mysteries of the early universe. As we continue to analyze and interpret these findings, we are gaining a deeper and more nuanced understanding of cosmic evolution and the fundamental processes that shaped the universe. Thank you for joining us on this exploration. If you enjoyed this video and want to stay updated on the latest space science discoveries, like, subscribe, and hit the notification bell.